We live? Okay. All right. So I'm just gonna be kind of going over some bug types, kind of like a basic overview, and then we can start looking at the OWASP juice shop and kind of go through some like methodology and how to actually like find bugs, vulnerabilities. So a little bit about me. My name's Corbin. A sophomore here at DSU. I do bug bounties. Here's my HackerOne profile if you want to check it out. There's my blog, GitHub, all that jazz. So I'll go through a little bit of like, I'm just going to kind of assume everyone works, but I'll do a really like brief walkthrough. So whenever you open your browser, say like you open up Chrome and you enter a URL, so say like docs.google.com. So your browser performs like a DNS query to get the IP of docs.google.com. And then your browser then sends an HTTP request to the web server. And then that web server receives the request and then responds with an HTTP response. So, I mean, I'll just show you kind of in Burp Suite what like a very basic HTTP request looks like. So I'll just trim this down. So as you see here, this is like anatomy of like a very, very basic HTTP request. So I guess I'll add a header too. So right here you have your method, then you have the request path, and then the protocol version. So this is HTTP 1.1. Then here you have the host header, and there's the host and the port you're connecting to. You can actually like probably remove this too. That doesn't matter as much. Then you have user agent header. Whenever you visit a website with, say, Firefox, that user agent will be a Firefox agent, and then we just send this request. Wants to go through. Then here you have the HTTP response. So here you have that protocol version, and then this is the status code. So I'm not going to go through all of them, but you can Google like HTTP response or status codes, and you'll get a long list of them. They all mean something. That's basically the very basic, kind of important to know stuff about that. So I'm going to go through some bug types kind of briefly. If you have questions, feel free to interrupt me. If you need me to explain something better, you can just ask me. Because I kind of threw this presentation together last minute. But so the first bug type I'm going to talk about is cross-site request forgery, or CSRF. So CSRF is a vulnerability in which an attacker can force a user to perform unwanted actions. I guess I should put this to present. Unwanted actions on a web application that they're currently authenticated to. So for example, say you're a user on vulnerablewebsite.com, and say there's a bunch of functionality, but one of the functionalities is you have like a profile and you have a bio. So like for instance, like Instagram, you can set a bio or whatever. And say this application doesn't do any checking on like where the refer is coming from, and there's no like unique tokens in every request to know that the request to change your profile is coming from that same website. So then you could visit a malicious web page at host, and it forces you to change your profile bio to CDL. I can Google an example really quickly to kind of give you like a visual idea. But the limitations on this type of bug is it's really dependent on user interaction. So like you basically have to social engineer in a sense, or get someone to click a link, and they also have to be authenticated to the application most times. Let me Google an example really quick. So if you want to learn about a bug type, one thing I really recommend is just using this door. Use just like site and then hackerone.com, and then literally just Googling the bug type will come back with a bunch of different examples of like real world reports that people have that have been disclosed on HackerOne. So so I guess this one, let's see, this was a CSRF vulnerability on Khan Academy that basically, I guess, I don't know, let's see, forced people to, I guess, sign up. It's kind of a really bad, like really low impact. I don't know why this is high. Maybe I just don't understand it. But basically, like an attacker would, you know what? Let me just kind of show an example too. Let's see. Let me create an account really quick. Oh, not yet a customer. I think this actually might be vulnerable. I'm not sure. So basically, say for instance, right here. So here in this request, we can see that it's really just this parameter that's being sent. So this is the username, then this is what I'm setting it to. I'm pretty sure if I engagement tools, so I host this CRF like attack page. I can force someone to change their username. So say I have my malicious page here. Oh. Say I want to change this person's username to loser or something. I could do visit my payload malicious payload page, and you can see it change the profile to loser. So like whoever was authenticated to this, visit that page, and update their username to whatever I specify it. So that's an example of CSRF. It's like a kind of it depends on, I guess, what functionality is on, but usually that's a to medium impact. Next bug I'm going to talk about is cross-site scripting, or XSS. So the gist of this is it's kind of a code injection, but like front end. So I think a better name to explain it is HTML injection, because the issue arises. The issue arises when user controlled input is unsafely reflected back into the page, allowing an attacker to inject malicious HTML or JavaScript. So that's usually dependent on being able to inject script tags, like image tags, or any sort of HTML tag. That's why I kind of think HTML injection is almost an easier term to use to explain it. There are certain times it's not always true. Like you can sometimes something you specify will be reflected back into like an attribute tag or in some JavaScript, and you'll be able to just break out with like a quote. So some types of cross-site scripting, there's like 3 types of it. There's reflected, stored, or DOM XSS. So reflected XSS is where the malicious payload comes from the current HTTP request. So let's see. I'll just make a really quick example. So let's see. I think this will work. So reflected is this is being sent in every HTTP request, and without this being sent in there, that vulnerability isn't like trigger. So that one's kind of heavily independent also. And then stored is essentially where that just comes, that payload is like stored in a database, and then it's stored in the database. So it comes from, so essentially like, for instance, say we have a DSU forum, for instance, and everyone can make a post and view posts. If that, say the post title, for instance, you were able to inject malicious scripts, that would be stored in the database, and when everyone else logs in, that will automatically trigger, and that's what that means when it's stored in the database. And then DOM XSS, that's completely like client-sided. That's not server-sided at all. I'm pretty sure that also usually requires some user interaction. less than stored, obviously. So the impact of an XSS is like, okay, why would I care? This is a pretty fun bug. I have a fun time with at least creating like good exploits for it. So impact on this is like you can literally do anything on behalf of a user on a site that's vulnerable. So you can literally make HTTP requests to any endpoints on that user's behalf. And then you can also view and exfiltrate cookies and just hijack user sessions. This one, just doing anything on behalf of a user is a lot more fun. Let me see if I can find some examples of that too. Oh, don't look at that. So like for instance, there was a website that I don't remember what this was for specifically, but this is an example of something that could be like used. This is JavaScript actually. So what it's doing is making an HTTP request to this like add user endpoint, and then what it's literally doing is just adding another user and making them an admin. So that's like an example of like actually writing an exploit to make the bug more fun. Next bug I'll talk about is insecure direct object references, or IDORs. So insecure direct object references are basically a single form of broken access controls. So yeah, broken access controls are just like a really wide generic name for this kind of bug class, but it's basically when restrictions on what authenticated or unauthenticated users are allowed to do are not properly enforced. It also occurs when like user supplied input. IDOR specifically occurs when user supplied input is unvalidated and access to the object referenced is provided. So I guess I'll go back to this broken access controls thing. So for instance, I can give an example of one that I found on a bug bounty program. So essentially, I came across this this one host and had an API endpoint on it that could update any news article, and it wanted authentication on certain endpoints, but there's this one actual like update thing that just was not checking authentication. So I was able to actually just create new news articles and also edit like current news articles on a very big site. That was just because they were not checking authentication. So that's an example of like, okay, these access controls are broken or just not in place at all. And then some examples of like where IDORs are usually found or like often occurs, like viewing a cart. So like usually have like, oh, your cart ID 1000 or 1001. If you change that to like a different number, you could potentially view someone else's cart. So it's usually when there's some sort of numeric ID that's tied to some object. So like for instance, also I've seen this in updating profiles on a website. So say you have a website again that you can change bios. Say your user ID is also say there's two parameters like where's Burp Suite? Say you have these two parameters like user like bio, and then you have like bio stuff here. I can't type. And then you have like your user ID. I'd say that's like 1000, like 100 or something. Sometimes, or I've seen plenty of cases where you can literally change that ID, and then that actually updates that user's bio or whatever the application has there. So that's a fun bug. I've seen it in order confirmations. So say you go to a site sort of like Amazon but vulnerable, and you place an order, and then you get one of those confirmation screens like, oh, thanks for your order. Here's your 100. Here's all the information about your order. Sometimes if that's numeric and you change it, you can get someone's information, someone else's order, and that has like their like phone, the card they charged, billing information, etc. I've also seen that in information before as well. So essentially, when you're looking for secure direct object references or just IDORs in general, if you see a numeric ID, just try changing it up like one up or like one down and see how the application responds. Or it depends also like what kind of application you're testing. If it's obviously something that's more sensitive, create a second target account, grab that ID and see if you can grab that while not authenticated to that certain account. Next, I'll talk a bit about path/directory traversals. A little generic, but it's a vulnerability in which an is able to traverse out of a directory and read local files, for example, coded credentials on the server the vulnerable application is on. So it's, I guess I've seen this in a lot of places as well. So usually whenever a application is trying to include some sort of file off the file system that is supplied by the user, a lot of times people can traverse back directories and read other local files that they're not supposed to be able to on a site or server. So, like an example right here, this is a little bit modeled off something I found like a month ago. So there's this one endpoint that was meant to load assets or like CSS files off a host. And like I said here, it's like it's meant to read CSS or JS files from var www static. But if instead of giving it like a CSS file in that directory, if you try to back and just read like Etsy password, it worked, and you could just read any other file off that server. So that's a very like basic kind of example. It can manifest in lots of different ways, though. If you Google zip slip, I've seen a lot of places that you can actually create a zip file that has a reference to a different directory that's just kind of traverses back, and it'll actually overwrite files. So I've seen people, for instance, like overwrite SSH keys or like SSH authorized keys by uploading a zip file to a certain site and then getting RCE from there. There's lots of different ways this can manifest, but that's kind of the gist, the basics of directory traversals or path traversals. Any questions so far? Take the silence as a no. If you do, just so yeah, here's kind of that example of a vulnerable, some vulnerable code. So as you can see, like it gets this parameter from the user, which is path, and then it directly tries to include it. So an exploit like this would work. So next we're talking about server-side request for or SSRF. This is probably one of my most found bugs, and this one's always super fun for me. I just enjoy the bug. So SSRF occurs. I can't type. SSRF occurs when an attacker can abuse application functionality to make HTTP requests to read/update internal applications. So one thing that I see a lot of people get confused about this is they think they see the client side fetch a URL, and that's not what SSRF is. It's always server side. So to try to give an example of where like SSRFs might exist in application functionality is, say an application fetches an image from a URL. Say you try to give it an internal URL and just see if it actually fetches that server. I've seen cases in bug bounty programs where people were able to fingerprint a bunch of internal applications just by like seeing what images are on internal hosts. So if you guys know what favicons are, so if I go to like, I wonder if Google has one. Yeah, so like favicons right here are basically just defined. Like if you look at the top of your browser tab, you'll see these little favicons whenever you go to like a site. So people are able to, like I've been able to before too, is like specify an internal 92 something and hit favicon.io. You can fingerprint a bunch of internal applications and see what they're running, whether that be like a GitLab instance, Jira or something. So that's kind of a neat thing. Another place where an SSRF might importing data from a URL. So say it has, you can, I'm trying to think of an example. So say you're on some sort of like advertising web application and you have a predefined list of like products that you want to import to your ads and run ads for. Say there's like a functionality that you can give it like, and that'll import all of your products into that ad manager. Say you give that an internal URL or just like something, internal, and it fetches that data, and then you can read the response of the HTTP request. I've seen that happen a lot. Publishing data via URL, we'll know what like webhooks are. I've seen those happen a lot in webhooks. PDF converters, that one's super fun. If you look up SSRF via PDF converter, or if anyone wants to hear more about that, they can talk to me later and I'll show you some examples. So basically any functionality that reads from or sends data to a URL could likely be vulnerable. Then exploitation. So whether an attacker can, lots of times like you either can just specify a completely different URL, or you can manipulate how the URL is being built or handled. I'm not going to get too deep into that one because that's a lot more advanced, and I'm going to just try to keep it more of like a higher level right now. So like more exploitation. I think someone briefly asked me about this a while back about just the metadata servers. So if a website is hosted by AWS or GCP, which is the Google Cloud platform, you can get security tokens or security credentials and gain access to either the AWS account or the Google Cloud platform account, depending on what it's on. So for instance, the AWS metadata server is the 169.255. I'm pretty sure that works for basically any cloud provider. And there's the latest metadata, IAM, which is their like role management, like user stuff, security credentials, and then the name of the role. So this role name isn't like the actual URL, but if you hit just security credentials first with the SSRF, it responds with that role name, and then you append the role name in the next request, and then it dumps out their AWS keys, and then you can export that to your terminal and run like AWS commands, and you're literally authenticated to their account. You can list S3 buckets. I've seen people literally get RCE because their role had like options to just execute commands on the instance. That's pretty fun. And then same with like Google Cloud platform, people can authenticate to people's GCP accounts or get a bunch of other secrets. So a lot of HTTP clients support URI schemes and HTTP and HTTPS. So lots of times I've seen you can get file read by this file URI scheme, or you can also send multi-line requests to internal services using Gopher. So like obviously there's a lot of other services that are running on internal networks that don't speak HTTP. So like for instance, like SMTP, which is that like protocol to send mail. A lot of times you can like hit an internal mail server. So I'll go over some like quick examples. So this one was sending emails from an internal SMTP server. So this is a bug I found a while back on a company. So essentially, I don't know if you guys have heard of Hacker Target, but there was this functionality on this company called Hacker Target, and what it would do is if you sent it a URL here, it would display all the HTTP headers back to you, like of the response. So what I started with is just trying to hit port 22, which is SSH, and as you can see, it responded with the actual like banner. I was like, okay, that's kind of interesting. And let me go back. Yeah, I reported that as is because I was like, okay, I'm just gonna like you can just hit an internal thing, and that's probably not supposed to happen. I told the guy, one of the guy who like runs it, I told him that it was vulnerable, and he said, yeah, it's not on my to-do list, but it's not really critical. Nothing you can really do with that. So then what I did is I tried looking to hit more internal services, and I saw that the port 25 which is open, which is the SMTP. So you can see it right there. When you try to get the HTTP headers, it responded things from SMTP. So essentially, it comes down to I was able to use that Gopher protocol to send all like the right commands to SMTP to send, and I could send emails from anyone at Hacker Target and it'd be trusted, as that was used for their whole mail system. So that one was kind of cool and a fun time. And then another example of like what you can do with like SSRFs and getting like this was turned into an RCE. So I don't know if you guys have heard of Shopify or not, but one of my friends found an SSRF on Shopify, and Shopify uses GCP, or the Google Cloud platform, for hosting everything. And so what he was able to do is hit the Google internal server and get like the service accounts tokens. And then eventually with that token, he was able to pull down their secret keys for Kubernetes. And then from there, he had root on all of their Kubernetes instances, which is really, really bad. So that was also a cool bug and a cool example of what SSRFs can lead to. Also, Capital One, I'm pretty sure they were hacked via an so that's also notable. Next, I'm going to talk about XXE. It's going to just talk about the very basics of XML just so people kind of understand it. But XML, or Extensible Markup Language, is a markup language that defines a set of rules for encoding documents that's both human and machine readable. And then I'm just going to hop over to Portswigger's little post about what XML is. This is the same company that makes Burp Suite. So this is kind of straightforward if people want to look through this. But yes, it's a language designed for storing and transporting data. It's got like tree structure. It looks a lot like HTML. Most people know what that, or should know what that looks like. So essentially, what are XML entities? XML entities are representing an item of data within an XML document instead of using the data itself. And then document type definitions of XML document type definition declares declaration document, etc. So essentially, you can reference other XML via an XML document. I'm going to try to just summarize it as that. And there are certain things called external entities that allows you to use like system or the public keyword to reference another, what was meant to be an XML file, something that's like external. So it could either be like a file or an external file that's hosted on a different site. So that's kind of the crappy gist of XML. I don't think I explained that great, but it's kind of hard to explain. So like XXEs, an XXE attack is an attack that is against an application that versus user supplied XML input. So this occurs when the XML input containing a reference to an external entity is processed by a weakly configured XML parser. So this leads to disclosure of confidential data. It's usually like source code, configuration files, any like local server file or stuff. A denial of service, that's usually done by the billion last attack. So basically, like entities are kind of like a variable in a sense. So if you specify towards other variables that specify towards other variables, it gets kind of like exponentially bigger. If you look up the billion laughs attack, that will probably explain it better than I did. But you can essentially DOS a system with it. So SSRF, like I said, if you can specify or within, if XXE works, like you can hit other internal applications, usually make requests to it and read the response from it. Then like that goes along with like port scanning too, from that perspective of the machine where the parser is located, and adjacent systems that's connected to that same network. So I'll go over some like examples to try to explain it better. But let's see what this other one is too. I don't remember what this one is. Okay, so I'll go over this one first, actually. So this is an XXE someone found in a. So essentially, there's a servlet on Twitter that was parsing XML somehow, and is expecting some sort of like XML like this. And what they're able to do is add a little document definition. So you have doc type foo, and then right here you have the entity, which is system. So that specifies like something external. And then they wanted to read Etsy password. So there's that file scheme, and then the Etsy password file. and then he has that right here. So that file thing basically gets expanded to, like I said before, it's kind of like a variable if you want to say it like that. And then in the response, it responded with the contents of Etsy password. So that's kind of, that is one example. And this next one is one I found on a company on a different platform than HackerOne. This is a published report. But so there was this company that was providing voice over IP called a bank. And you've gotten a robot voice saying like, oh, press 1 person, press 2 for your bank information, like stuff like that. This was the company that let you create those bots using voice XML. So voice XML was a digital document standard for specifying interactive media and voice dialogues between humans and computers. It's used for developing audio and voice response applications. So this voice XML language or document standard was built by someone else, but it's basically just XML. And so what I was able to do is I was able to read files. So like whenever you were, I guess I go back a little bit. Whenever you were creating a new phone bot, essentially they would ask you to specify a voice XML file to give that would specify like instructions or what the bot was supposed to say or how it would respond to different input. And I figured out if you put in malicious, like a doc type with malicious entities in it, it would actually, the bot would actually process that. So I figured out a way that I set up a whole new phone bot and then created a payload so that whenever I called it, it sent me the contents of the file I wanted to read back to my system. So yeah, that was a fun bug as well. Oh, that's not what I want to do. So next bug I'm going to talk about briefly is SQL injection. So SQL injection is kind of straightforward in the name, but essentially it's a vulnerability to inject their own SQL queries within queries that an application database. It essentially occurs whenever SQL queries are built around user-controlled data. This allows an attacker to insert, modify, exfiltrate, delete records within a database. For example, say you have this site, vulnerablesite.com, and you have this products.php file, and then you specify a product ID, and then it responds with like the name, like the description of the product, and like visualize in the backend that it's just I'm building this SQL query where it's literally just select name, description from products, where the ID is, and then our user controlled ID. So that would be injectable because it's not doing any sort of like escaping, or there's no like parameterized queries or anything. So we'd be able to inject our own SQL and like exfiltrate all the data in that database, or even like just update products or change products or delete them, etc. Whatever the application is doing. Here's a little example. Like this would be a vulnerable request just to make the database. Yeah. I think I don't know how much I have this. I have like 2 more. So second to last one, I'm command injection / remote code execution. So this is like such a generic bug class that people like ask me, oh, how do I find RCE? Really kind of difficult to explain because it's just so generic. But essentially, any of these command remote code executions, all this occurs when it's a vulnerability in which an attacker can execute malicious commands on a machine. Happens when user controllable data is passed into a string that's dynamically evaluated by a code interpreter, a shell of some sorts. So I think, like for instance, say there's an application that does there's like a functionality in application that runs ping, and all you do is enter an IP address, but that IP address is actually just used in that shell command. That user controlled data is thrown right into a like an exec function. For instance, you could likely just inject your own commands right after that, and it'd be executed. But again, like I said, this bug class is super generic because there's so many ways that this occurs. A lot of times in web applications, I've seen on like Java-based applications or even PHP, there's like deserialization for like Node.js and Python, even like Spring, Java applications, server-side template injection is a big one. Flag injection. For instance, if you look up GitLab on HackerOne, I'm pretty sure they have some examples of being able to add flags to a command that's being run in the back end, or just unrestricted file uploads, etc. So like unrestricted file upload, say the application is running on PHP and it wants you to upload, lets you upload like a profile picture. Say instead of uploading a profile picture that's like a .jpeg, you upload a .php. In the uploads, you could get command execution because PHP is installed on that system and the web server is configured to run PHP, and you could literally just upload a shell. But yeah, that is like super generic bug class. And then logic bugs. This is the last thing I'm going to talk about. Also very, very, very generic. The gist of this is like you literally, to find these bugs, you just go through the application and figure out what's happening, and just try to abuse it, right? So an example of what a logic bug could be is, say you have an application where you have like a bunch of different products and you can order products. Say you try to add a product to your cart, right? And it says like, okay, +1, +2, however many you want. Say you intercept one of those requests and then set that number to like -10 or something. Sometimes it'll actually go through and then you could check out. And then once you check out, instead of say that it's like $1 each, if you do specify -10, it'll charge you -$10, which inserts $10 into your wallet. So that'd be an example of a logic bug. So here's some resources to actually like learn about these vulnerability types, get like experience. Stanford, I think like this or last week, just posted a full web security class. I went through it a little bit and it looks pretty solid. There's like course materials and videos, even assignments. HackerOne has a free security course with CTFs, and that's HackerOne. Great. Portswigger, the same company that made Burp, a bunch of great free labs, and like each bug class has like 5 different labs to go through like different types of attacks, which is really great. If you want to learn more about SSRF via PDF generators, there's a few links. Then there's SSRF and cloud providers is kind of a little more about exploiting that. I can post this presentation somewhere else. So any questions on that? Take that as a no.
Thanks for sharing, Corbin.
Yeah, I can. Yeah, and if we want, we can start looking at Juice Shop a little bit. Can talk about what some methodology would be like. So, is that cool? Cool with people?
Yes,
Cool.
let's do it.
All right, let's do it. Just interrupt me like whenever. Ask what I'm thinking if you're curious. So, let's see. I'm just gonna leave these. So I have Juice Shop running here. So say it's like the brand new web application. Say we're just gonna try to attack this now. One of the first things I would probably do, a good tip when you're trying to attack stuff in bug bounties or like whatever it might be, pen test, a red team engagement, is instead of just going full in like, okay, I'm just gonna try hack, just take a second and just click through everything and try to figure out what is happening in the application. Just try to understand the actual functionality of it. And if you have Burp Suite open, what's super great is literally everything, all your traffic to be tagged here. You see all your HTTP history will be literally just be in Burp Suite later, and that's super cool if you want to go back and just kind of find API things to go through one at a time. So I'd always recommend going through that. So yeah. Also, another thing I like to do is literally pull JavaScript files off. So like for instance, this is React, I think, or I don't know what it is, but it's very like JavaScript based. So what I do is I usually look for, so there's all these JavaScript files. You see there's a runtime, polyfills, vendor, these main files. So I usually pull these main files down because this is usually where all like the juice is. No pun intended. But let's see. So what I usually do is, let's see, CLO. Let's pull this down, and then there's this like tool called JSBeautify. I think that's like a node. It's built on Node.js or something. But opening this up and just being able to figure out kind of what's going on. A lot of times these will have all the API endpoints in it, but I usually start with this too. I'll just open this in the background for now. But actually, you know what? So one of the first challenges of all is to find the scoreboard, I think. So if you go through here and what is it? Router link. Actually, I'll just look up scoreboard. Here we go. So I'm just going to do that scoreboard first because it tells us about the vulnerability types too. So I'm just going to open that up first. But like I said before, when I usually attack a web application, I just try to figure out what's happening. So for instance, I'm just going to register for this again. I did it back in the slides, but I'll do it again. So password. Okay, I don't care. Set a security question randomly. And then let's kind of see what that looks like. You see it's making a post request to this API with the email and stuff. So I should follow my own rules. So let's see. Oh. Okay, so we're logged in now. As you can see, it looks like there's a bunch of products. Looks like we can write reviews for products. We can add stuff to our basket. We can remove stuff from our basket, change the quantity. Let's see, we have customer feedback here. We can make complaints, and there's a file option here. There's an about page. There's a photo wall. We can add our own pictures to it. This deluxe membership thing. Become a member. Let's go to the account settings now. So we can set our usernames. We can upload a picture, or we can specify a picture via URL using Gravatar. What else can we do? We can look at our order history, recycle, all this privacy stuff. I don't know why that's a challenge. Read the privacy policy. Can export your data. There's all sorts of functionality here. Payment options. All this jazz. So I think we can probably just start attacking this. So, oh yeah, there's search functionality too. So let's see how the search is working. We can see that our search query is actually being reflected right back into the page. So I've seen this a lot of times in just general, like real world, is that sometimes this will be vulnerable to XSS. So in my mind, if I see something that I control reflected back into that web page, I'm automatically thinking, okay, this could potentially be an XSS. Maybe I could try a server-side template injection if it's doing any templating. So I could do like, could guess like stuff like that. Like, okay, no template engines are being used here. If you want to look up more about server-side template injection, it's a pretty neat vulnerability. So we see none of that's really happening. So let's just try injecting like HTML. So these are the underlying tags. So we can see that it's actually being underlined, and that's actually being like parsed. So if we try something like CNG SRC on air, we can see that actually is injected into the page. So yeah, as you see, that works. I think the actual challenge is to use this though. Sweet. So this would in general kind of be like a reflected XSS as it's like in this current HTTP request, but like it looks like it's a requested XSS, but it's actually DOM XSS because of this. It's all client side. Nothing's actually being sent to the server right here because that. So I guess next, what should I look at? We'll just go through the process of actually something. So let's add something to a basket. But I didn't even change anything. I don't know why I saw that. But okay. So, okay, I'm confused why that happened. What is happening? Wait. Okay, I'm gonna log out and log back in again. I don't know. It's not working. There we go. Placed apple juice into basket. So we'll go to our basket now. Let's look at adding something. So let's say we want 2 of these. It intercepts that HTTP request that is actually adding stuff to the basket. So you can see here in the body of this request, you have this quantity and it says 2 here. So this is a place where I would look for business logic bug and see what would happen if I, say, for instance, wanted -10 apple juices, because that makes a lot of sense. So yeah, let's update this to our basket to have -10 apple juices and see what happens. So yeah, it looks like it let us do it. I guess I didn't see the response from that, but that's fine. Didn't get an error yet. So let's try to check out with 10 of these. So go to checkout. So you can add addresses. Let's just try to add random stuff. And these. That. So it lets us add an address. Choose the delivery speed. So we're just gonna go through like the normal checkout options. So it's just like, okay, actually standard delivery, it's fine, doesn't matter. I'm just filling this all out like arbitrarily, get to that final result of the actual checkout. Payment options. So as you can see here, pay -$19.90. Because we added that -10, I think it was $1.90 each, $1.90 each. So that amounts to actually -$19.10. So if we click pay or just continue, I guess. Total price -$19.90. Place your order and pay. And now if we go back to, I think it actually shows digital wallet. Now we can see that our wallet balance is actually $19.90. Yeah, so that's an example of a business logic vulnerability where it actually, we went through and it actually gave us money because we entered a negative number. So that's cool. Any questions so far? Nah. Alrighty. So trying to figure out what to look at next. So let's look at order history. And the order confirmation, that looks interesting. No, not what I wanted. There's this FTP directory. Wow. I'll look through this later. Because I want to look at like actually attacking the application. Actually, you know what? Let's just go through the scoreboard and try to figure out how to. Let's just try to find something cool. I'm going to my account. So let's play with this Gravatar URL. So let's try entering a URL like I control. That's this on port 1337. Let's do intercept that request. So basically, I'm just going to try to see if this is actually from like this URL server-sided versus client-sided. So link gravatar. Here's the HTTP request. As you can see, that's what I specified. Send that to repeater. And as you can see, yeah, right here, the application actually makes that HTTP request, and it's not my browser. If it was my browser, it would be there have like user agent and a bunch of other stuff usually, I think. Also, to differentiate between like what server, usually you can just tell by where you're getting connections from. Like if it's not your IP address, then it's server-sided. Right now, it's going to be my IP address. This is running on Docker locally, so yeah. So that appears to be an SSRF vulnerability. I'm not sure how they validate that though. So if I do like localhost favicon.ico and I reload that, I'm just trying to think of something internally I could hit. I'm not sure how this is all set up, but so let's try giving it this internal URL. So it's kind of hard to explain since I'm already on localhost. But say this application wasn't running or like wasn't bound to like localhost. Say this was on like example.com, for instance, and I was able to hit localhost. Like I shouldn't be able to do that. So that's why it's internal in that sense. So as you can see, it actually fetched that URL like localhost, and it shouldn't do that. So that's an example of an SSR. In these cases with like images, a lot of times you can fingerprint a bunch of internal servers, like I said, or like even one-shot RCEs, where you can still make an HTTP request to something internal, get an RCE back. But I'm not going to go into those specifics, kind of like situations, because it's very like situational, and you have to know their internal network layout. So I guess next I'll talk about, I'm going to try this username functionality. So something I'll try here is I'll try maybe like XSS or server-side template injection, because again, right here, it's being reflected back to us. See, that's all taken out. Yeah, so it's doing some sort of like stripping that tag. I'm gonna just try some template injection stuff. So like sometimes 7. No. So there's lots of different ways, like different engines do templating. So you kind of just play around with the ones that you're aware of. So another like template syntax is this. Oh, and as you can see right here, this actually parsed that template right here. So that's 7 times 7. It actually parses the template and executes that server side and does the math. So what you can do from here is, let's try that. So yeah, as you can see, you can, I don't even know how to explain this because this is Node.js. Yeah, I'm just trying to figure out how to do this. Yeah, it's kind of hard to explain, but if you Google server-side template injection, they'll give you a lot more information than I can just off the top of my head, because explaining is hard. But like I said, this is running, I think it's Node.js in the backend, so we can probably get code execution from this. So if I do Node.js SSTI, not what I want to do. So if we look at the syntax, so this looks like it's probably Jade just by, I don't know, seeing this sort of syntax that is similar to the one that we have. So we have that final exploit looks like use global. It's an object global. I don't know how that differentiates from, oh, they're the same thing. So I don't even know how to explain. You can look it up. But essentially you can hook in, I think, was it child process, and then just execute commands. So let me try like, I don't know if this will work or not. Hey, it actually worked. So essentially you can hook in some other like underlying processes and require child process, which has that exec function, and then from there you can literally just execute code on this. So instance, let's see, post file. Actually, I guess I could just do it. So then from there we can just spawn a reverse shell. I don't know if that actually worked or not. Probably not. Classic. Cache mod plus X. Oh, I guess I should set up listener. And it didn't work because live demos never work. Anyways, I've already downloaded it though. One sec. Oh my gosh, was I missing a quote this entire time? What is going on? Yeah, this will probably just work. First shell. So Firefox. And that didn't work either. But yeah, an example of server-side template injection, which leads to RCE in this case. Should I look at next? Any questions? I know I'm not good at explaining stuff. No? Cool. So let's look at this complaint form, because earlier I saw this upload functionality, which is obviously pretty interesting. If you see anywhere that you can uploads, look at it and spend a lot of time on it, because it's usually really interesting backend stuff is happening, and it'll probably be vulnerable to some sort of thing. Usually it's just like a juicy place to look. If you find something in it, it's probably going to be a high or a crit. That's why anything that's more has a lot of like server or functionalities, usually server side bugs in general are just a lot more fun. So let's complain. What I like to tell you, you suck. I can't spell. And then I'm just going to inspect element and see what kind of stuff it's expecting us to upload. So it says expects or accepts PDFs or zip files. But then it also says input for uploading a single invoice, PDF or XML. So that's interesting, or zip archive. So I'm going to try uploading an XML file, because we talked about XXE earlier a little bit. And if it's potentially parsing that in the back end, that would be neat. And we could probably get file read from that. So go to my desktop. Let's see if I have. Hey, I do. So I built this really easy thing to just generate XXE payloads. So if you go to xxe.sh, you can really just enter your domain, and then you have this payload that you give directly to that parser. Then you host this at xxe.ddd, and that would send you the contents to your FTP server. But I'm just going to do this. I already have one right here. So as you see, it's just a very simple XML document. We just have our type, which is hacks. And then we have our, I guess, external entity, which is pointed to x.xxe.sh. I'm going to change this to, since we probably want to read files because that's interesting. So I'm actually do this. And let's go back to Firefox. Desktop. Well, all files. I don't care. Hello. Okay. I didn't even. Okay. So it looked like that worked just by it saying I solved it, but I didn't even intercept that request. So let's try that again. Submit. So here we have our XML file, and this, which is our payload, and then intercept the response. Gone. You can see right here, render this. It's easier to see. So as you can see, it actually worked, and customer complaints via file upload has been appreciated. And then we had our malicious XML here. But then you can see is the hacks tag we had, and then it actually expanded that a entity and just responded with the contents of Etsy password. So from there you could read like configuration file, other internal services, all sorts of stuff. So that's an example of an XXE. Any questions? So it also said we could upload files. I think one of these challenges so I'm just gonna try uploading a normal file just actually. Yeah, we're gonna try upload. Gonna make a dummy zip. Let's just do touch X. This should just. So let's up. Not sure what can show up. Second. Let's just try that again. Oh, so this is interesting too. So when we make a complaint, see right here it has this ID. So what I would do here as well. And as you can see, we didn't get an error or anything, and actually, and then it says that user ID, and they complained with. So that's an example of an insecure drive. So we can actually make complaints on behalf. Yeah, so that's kind of a cool example.
Not sure if it's for anyone else, but you're cutting out a little.
Same.
I'm cutting out a lot.
Yeah.
Yeah.
You might have to increase your Discord mic sensitivity, mic activation sensitivity.
I don't even know if it's that though. It might just be. Is my stream lagging at all? Is it just my?
No, go to voice and video under your Discord setting. Yeah, and then turn off the automatically determine input sensitivity and manually adjust it.
Oh, that's lame.
See, it's really high, so
yeah, it is high. Cool. I don't know how to Discord. Thanks. Is that better now?
Yes.
Cool. Thanks. So I'm not sure exactly where that is being uploaded to exactly, but I'm going to guess it's probably in this FTP directory somewhere like further up. So say for instance, I could try something like that zip slip thing I talked about earlier. So if it's up a few directories, I could probably overwrite some of these files or any of these files. So let me just try uploading something first without overwriting it. So let's make hacks. That's it. Let's remove this. So I'm gonna make a file or directory 1, cd1, and then I'm gonna make a directory called FTP. And FTP, we wanna make a file called traversal.md. Oops, so laggy. Traversed, and then in a different directory, we're gonna create one called 2, and then cd2, and then right here there's that directory traversal right here, right? So we go back. I think it's actually in only one directory. If we do traversal.dat, as you can see, if you try to just list the contents of this zip file, you can see there's that actual traversal in the name. So a lot of times if people are vulnerable to this zip slip thing, you can actually traverse back and overwrite files or just write new files into different paths. So I'll try uploading this. I don't know if this is right. So we have 1, 2, exploit zip. Just see if that's in here or not. So that didn't work. I don't know if this exists. No. Okay. So I'm going to try traversing back 2 directories instead of just 1. So exploit.zip. So as you can see, I just added an extra that / traverse back another directory. So I'm going to try uploading this again. As you can see, it actually worked, and it's able to traverse back into this FTP directory and write my file into here. So for instance, I think they have this legal.md, so I think this is actually a challenge. They have this, yeah, it is a challenge. I did it earlier. They have this legal information file. So for instance, like if a company had this something on their website, it would probably be bad if that were to change to something else. So if we do like FTP legal dot is legal start the purge. Oh my gosh, can't spell purge. And then we do legal.md, and then write that, submit it, and if we go back to this legal file again and reload it, we see we overwrote that legal file, and so everything's legal, start the purge. So like practical exploitation of this is like that. You can traverse back and overwrite anything. If you're on like a Linux system, you could overwrite authorized keys and get RCE via that way. So yeah, that's another bug. Any questions so far yet again? No. So I guess another thing I would try here in the login page is a SQL injection. So there's this classic, what is it, or 1 equals, is it 1? Actually, I need to move these quotes. So I tried doing both email and that password and tried logging in with that. I don't know if that'll work or not. Yep. So essentially it was building a SQL query with, it might look like, let me see, in Sublime. I'll select, I'll Google it. Essentially you can bypass like conditions for like logging in on stuff with a SQL injection if it's on like a login, for instance, where it's like select star from users where name equals, and then like the stuff we enter. So it's like if it was looking for the email or like the password, it's trying to do like a type check versus like what you entered and then like the hash that's stored in the database. But if you're able to just like insert anything here and enter have this or statement, so it's like, okay, either your password is right, and then if you inject that or 1 equals 1, so it's like, okay, well if the password isn't right, does 1 equal 1, and if so, log in. So that's kind of how that works in the basic gist of it. So that is a SQL injection. So you can see we're the admin now. This is the thing. Illustration. Cool. I'm gonna log out again. Actually, I'm gonna try something. Oh my gosh, why didn't it? Do you want to accept response to this request? Is your token? Okay, I'm gonna do this. All right, never mind. I'm try to see something, but it doesn't matter. I'm gonna log back in really quick. Anybody have questions? Go back to this customer feedback page. I forgot about this. So here'd be another example of kind of like a logic vulnerability is, so we have this comment. We have this CAPTCHA. Actually, I'm just reload this because I think there's two vulnerabilities here actually. So we have this contact form. I guess. So we have this CAPTCHA at the bottom right. So it's like expecting CAPTCHA is basically used to like prevent people like robots from, I guess just people from like automating stuff. for instance, like if you go on Google and just Google a bunch of stuff in the span of like a few minutes, or use a lot of Google dorks, you'll probably get those captchas or recaptchas where you have to, it says like select all pictures that are of a fire hydrant or something. You have to just like select all of those. I think this might actually be of like an example of like a bad implementation of one. So if we go to, I don't know where it went, rest dash captcha. So if we do this, you can actually see it has that question, but it also has the answer and the response, which is just not smart, because then what you do is say you wanted to make like a bunch of customer feedback requests in the span of like however long. You literally just hit this endpoint first, and then like have that bot fill out a bunch of comments, and like every time you submit a comment, you just make a request to this first and grab the answer of the generated captcha. So that's an example of just like a bad implementation of a captcha. I don't even know what that would fall under. Probably just like a business logic vulnerability as well. Yeah, but again, so we can, going back to this without even the captcha thing. So I can just leave a comment, and as you see here, we have this like rating system. So it's like 1 to 5. But what happens if we try to enter a rating that's like out of that range? So for instance, let's just try to submit this at 5. Something I would try is either going over like 6 or underneath. So I'm gonna go for 0. Sometimes there'll be like integer overflows or underflows. Actually, at the last live hacking event I was with, I was at, one of my friends found a vulnerabilities in a system that like allowed people to rate certain products 0 to 10, but if you put it over 10, it would just crash the entire system and like all the nodes. So that was kind of funny, but also like not bad, or not good. But that would be an example. As you can see, it actually went through, and we were able to give a 0-star rating. So that's also a logic vulnerability. Trying to think of anything else. Does anyone else have questions? And there's a lot of functionality here, so I don't think I'm probably going to go that much further into this, as there's some vulnerabilities in it. But yeah.
Corbin, I've got a question.
Yeah.
Where can I find this mystical juice shop at?
OWASP juice shop. Google. If you want, there's the GitHub for it. I can post it in the Offsite Club Slack. I'll post the slides in there later too. But if you have Docker installed, it's really easy to spin up, or you can even use Roku for free apparently. So that's cool. Any other questions? Take that as a no. But yeah, if anyone has any questions about like vulnerability types or like attacking certain things, or if you just want to get into like bug bounties in general, feel free to ask me. If you have any more like advanced questions, feel free to ask me. That was kind of a basic overview. I probably didn't do like an amazing job of explaining anything. So if you do have questions on like XXE or something like that, for instance, I'd be glad to help you figure that out. Thanks, Jared. Oh, thank you. All right, so Kyle. Thanks,
All right.
Nick.